Eco-band and inclusive variable for deaf and blind communication using hierarchical tick encoding and HAI. So Eco-band is a smart wearable device designed to bridge communication gaps for individuals who are both deaf and blind. Unlike traditional assistive tools like tactile hand signs and braille scripts, Eco-band translates real-time spoken language into distinct vibration patterns on the user's wrist using a novel hierarchical haptic encoding system. It leverages HAI models like Whisper, Tiny and Voice, enabling offline speech recognition in Indian languages. Now my friend is going to go into the technical details.
Hello. When it comes to technical details, we have implemented the prototype using ESP32 microcontroller. And as you all know, ESP32 microcontroller is one of the most powerful microcontroller which runs on 240 Hz frequency, and it has capable amount of 48 GPM. So when it comes to implementation, the board which we have used is 30-pin development board, and for which we have integrated I2S microphone, which is INMP441 I2S microphone module, and we have connected it to an I2S standard interface number 1, which includes pin number 25, pin number 32, pin number 33, and pin number 14. And for hierarchical haptic encoding system, we have used 4 different vibration motors, and to drive them, we have used ULN2003 driver board, which is capable of driving 4 motors individually at a time. So we are using standard digital to analog conversion DAC interfaces, which is present on ESP32 microcontroller, which takes a pin number of 25, 26, 28 and 14. These 4 DAC pins manage to work individually by implementing a haptic encoding system. And here is the demonstration. Let's go with the technical implementation for the Eco-band. When it comes to technical implementation, we use words to haptic feedback encoding, which takes a word sequence like a word and it decodes it and then plays its haptic encoding format. And haptic encoding is played with this module, which is made using ULN2003 as a main ULN2003 as a main driver, and we have 4 vibration motors which will be driven using ULN2003. And the input from the ESP32 microcontroller, which is basically a 30-pin microcontroller board. From that we use DAC and digital to analog conversion modules, and then the digital to analog conversion modules writes to the input of the vibration device we have made, haptic encoding device, and then the encoding starts. And let's test with our encoding format. Like let's try with a command called emergency. So the format of emergency plays, and now let's try with another word.
Navigation.
The word navigation.
Query.
When it comes to
communication. Help.
And now when it comes to details about remaining modules used in this, we have used an I2S mic for the microphone input to the ESP32 module, and we used SIM800L, which is basically a GPRS and GSM module, which helps when the caretaker is not around us or we don't have any access to this device. From caretaker there will be an SMS message sent to this module, which will be decoded and played, and the decoded text will play text haptic feedback response will be played in the device. Thank you.
Thank you. We have already seen the first functionality of Eco-band, that is commands to haptics encoding. Now we will see the second functionality of the echo band, that is will provide an user interface to the caretaker of that physically challenged person, and the caretaker can give commands to the echo band and for the haptic encoding.
So when it comes to haptic encoding, when the haptic encoding UI is made basically using WebSockets, and our ESP32, which is a main microcontroller, acts as a server. And this server serves a web page in which WebSockets are used, and there are buttons for each and every command need to be given. Now let's have a demo of commands. When we give a command like this, emergency, the vibration sequence, a haptic encoded vibration sequence will be played in the device we have made. This is actually a band, echo band. Now when we actually come up with an explanation on how we actually made this, we have been using ESP32 dev module, which actually contains ESP32 WROM32 module, which is 30-pin board, which uses 240 MHz microcontroller with an enough number of GPIO pins, like 30 pins, which have 3.3 volts power interface and 5 volts power interface, with many protocols like I2C and I2S. In fact, we are using I2S for our microphone, like we are using I2C microphone to connect to it, and we use UART, like universal asynchronous transmission and receivers, to communicate with the SIM module, which actually sends the GPS, which actually sends GPRS signals to this module, and these signal encoded message will be sent to our caretaker. Now we come up with a detailed explanation how this actually made. We have connected a driver board called ULN2003, which is an NBN transistor array. We are driving 4 different vibration motors placed at 4 different locations, so that user understands about the different vibration sequence and different motors. We play each motor once with a vibration sequence, so that user actually understands what sequence is being played. Thank you.